So to finish this chapter, I would like to discuss with you an application example. And here I would like to discuss with you ethinylestradiol, which you might all know as so-called pill. And here you can see the synthesis of the pill, and at first glance it might look quite difficult. However, I will now guide you through it, and at the end I hope that you will see that the most important steps of this synthesis are exactly what we just learned. So if we have a look on the starting material here, we can see that the starting material contains 2 ring molecules and 1 carbonyl group. This carbonyl group can then act as electrophile with the so-called Grignard reagent. And we can see that the double bond of the Grignard reagent will add to the carbon of this carbonyl group, and hereby a new carbon-carbon bond is formed, and finally the organic part of this Grignard reagent is added to our starting material. Moreover, an alcohol is also formed at this step. The second step then comprises a cascade of reaction steps, and finally we introduce 2 new ring compounds. Here a dicarbonyl compound is added, and you can see that we have 2 carbonyl groups in this compound. In the middle we have a methyl group and also 1 quite acidic alpha hydrogen. Accordingly, the enol form is quite easily formed, and then we have 1 remaining carbonyl group which will be then attacked by a nucleophile. And in our case, the nucleophile is the carbon-carbon double bond. Hereby a new carbon-carbon bond is generated, and after this cascade of reactions we will end up with 2 new carbon-carbon double bonds here and here. And these carbon-carbon double bonds are formed by the elimination of first the initial alcohol, so of this part here, and second of water from the second carbonyl group. Then in the third step we conduct a so-called hydration of the double bond, and it will selectively be this carbon-carbon double bond which gets hydrated. The reason for this is that we use palladium and calcium carbonate. And if you imagine, we have now this quite large molecule, and in order to hydrate this double bond, the complete molecule will interact with the palladium surface. We could also imagine that the complete molecule lies flat on the surface of the palladium, and then the double bond can become hydrogenated. And then the hydrogen can only come from the bottom side of this molecule plane. If you have a look again on this molecule, we can see that here is a methyl group which sticks out of the molecule plane. So if you imagine that the hydrogen would approach from the top side of the molecule, then we have this methyl group which hinders the accessibility of the molecule. Hence, the hydrogen will always approach from below the molecule plane. So then we end up with this molecule here. In the next step, this diol, which is called 1,2-ethanediol, is used to form a protecting group for the carbonyl group. And this step is conducted in acidic conditions. So this carbonyl group will then be protected with an acetyl protecting group. And then in the next step we conduct again a reduction, this time with a stronger reducing agent, lithium in ammonia. And if we would now not protect the carbonyl group, we would also reduce the carbonyl group towards an alcohol. However, this we definitely want to avoid. That means we only hydrate the carbon-carbon double bond, and we end up with a carbon-carbon single bond in this step. The next step is then a deprotecting step in order to remove the protecting group and to regenerate the carbonyl group here. And this step is conducted in diluted acid water. Subsequently, another deprotecting step follows, and this step is now new for you. Here we have a methoxy group as protecting group for an alcohol. Hence, in this deprotecting step, we regenerate, or we deprotect alcohol, and we end up with the formerly protected alcohol group here. The last step is another nucleophilic addition reaction at the carbonyl group. Here you can see that we now use an alkyne molecule as nucleophile, which will attack the carbon of the carbonyl group. And hereby a new carbon-carbon bond is formed and the alkyne component is introduced into the molecule. Moreover, we can also see that a tertiary alcohol is formed. And this final product is called ethinylestradiol. And this name already indicates the main functional groups. Ethinyl, as we have an alkyne component, estra, as we have a steroid structure here, the 4 rings, and diol, as we have 2 times an alcohol group here in the molecule. So in summary, we have 2 nucleophilic addition reactions at a carbonyl group, first with a double bond and then second with a triple bond. Moreover, we have acetal as protecting group for the carbonyl group. That means we first introduced this protecting group. Then in the second step, we have to remove this protecting group in order to regenerate the carbonyl group. The third type of reaction is an alkene reduction, which we have 2 times, here and here. And in both, we use a different type of reducing agent. Now, I would say this application is very nice to demonstrate what we all learned in the last lectures. And you can see that the types of reaction we just learned are quite important also for the daily life. And yeah, to finish this lecture, you can do the worked example 23.4 and 23.5, as well as the end of chapter question exercise 5A and C, and exercise 6A, B, and C.